Welcome back. Problem 11-24. So statement of problem is the shaft is supported by smooth thrust bearing at A and smooth journal bearing at B. If P is equal to 10 kilonewton and shaft is made from steel having allowable normal stress is 150 megapascal and allowable shearing stress is 85 megapascal. Determine the required minimum wall thickness of the shaft to nearest millimeter to safely support the load. So you can see this is the shaft that is supported by at A thrust bearing at N and at B there is a smooth journal bearing and load is applied at this point which is P and P is 10 kilonewton. The cross section of shaft is that it is a hollow circular shaft with the outer radius 80 millimeter and inner radius is Ri which is not given, so you have to find this thickness T. So let's start with the solution. So basically here we will apply this formula. Allowable stress is equal to maximum bending moment into C divide by I, where M is maximum bending moment, C is distance from neutral axis till the topmost, I is moment of inertia. So by using this formula we will find this thickness T. So first step is that if you remove this thrust bearing, so you will be definitely having a reaction force. Let this is Ra, and if you remove this smooth bearing at B, so you will be having reaction force Rb. By using symmetry about the mid, you can see that this Ra will be equal to Rb and that will be equal to P, which is equal to 10 kilonewton. But I will solve it for you to show you that Ra and Rb is equal to 10 kilonewton. So first step is that sum of all moment about point 1 is R point A, which is this one, is equal to 0 and taking the counterclockwise moment as positive. So about point A, one moment is due to P and perpendicular distance is this one and this is clockwise, so it will be negative. Second moment will be this P and perpendicular distance is now 2 meter and this is clockwise, so it will be also negative. The third moment will be Rb into perpendicular distance is now 3 meter and this is producing counterclockwise, so it will be positive. But the sum of this and this must be equal to 0. So I will write P into 1 minus P into 2 minus plus 3 into Rb is equal to 0. So minus P minus 2P plus 3Rb is equal to 0. So minus 3P plus 3Rb is equal to 0. So from here you can see that Rb is equal to P and that P is given as 10 kilonewton. Now you can find Ra by using this condition, and the condition is that sum of all forces along y direction must be equal to 0 and force upward is taken as positive. So one force is Ra, which is upward. The other force is this P minus P. The second force is also minus P plus Rb. Rb is P is equal to 0. So this will cancel with this, so we will get Ra will be also equal to P and P is 10 kilonewton. Now you have both this reaction force, so by using these two forces we will draw the shear force and bending moment diagram. So what we will do is that we will take the vertical lines from the end of the beam. Similarly from here you will take the line and then there is a horizontal line to show the length in meter. X will be in meter. Here you will be have shear force in kilonewton. Let each division is 5 and this is 10 kilonewton. Similarly minus 5 and minus 10 kilonewton. Now at this point you can see you have A, which is Ra is 10 kilometer Newton into meter. So first point will be this point. There. Now moving between point A till this load, there is no other force, so it will remain same till this point 10. Now here you have minus 10, minus P, which is minus 10. So shear force will plus 10 minus 10 will bring it to 0. Now moving from P to till this P, there is no other force, so it will remain. There will be no shear force till this point. At this point you have minus P, which is minus 10. So shear force will change to minus 10. This is minus 10, and again from till end there will be no other shear force, so it will be same. And at this end you have RB, which is equal to 10 kilonewton, so it will bring it to 0. So this is your shear force diagram. Now we'll move toward bending moment diagram. So while drawing bending moment diagram, again there is a horizontal line to show x in meter. And now you can see the first area under the shear force diagram. Moment about first point will be 0 because x is equal to 0. So your first point will be this one. Okay. First point will be this one. Now area under the shear force diagram is this area. So this area is 10 into 1, which is equal to 10. So at this point we have moment. Okay. We have moment, and let each division is also 5 10. So 10 minus 5 minus 10, and the unit will be in kilonewton into meter. So your first point under the shear force diagram is this one. This is 10 kilonewton into meter. Now the area, the shear force diagram is a horizontal line, and this is positive area. So bending moment will be 1 degree higher and slope will be increasing. It will be a 1 degree straight line. Now you can see this region that there is no shear force, so bending moment will remain same till this point. So it will remain 10 till this point. 10. Now the area under the shear force diagram is this area, and this area is minus 10 into length, which is 1, and this is equal to minus 10. So shear force at this point it will be equal to 10 plus minus 10 will bring it to 0. Since the shear force is a horizontal line and area is negative, so bending moment will be 1 degree higher and slope will be decreasing, and it will bring it to 0. So now from BMD, bending moment diagram, this is BMD, you will get maximum value of bending moment comes out to be 10 kilonewton into meter. So we have the formula: maximum bending stress is maximum bending moment into C divided by I. Clear? So we have this value. So if I draw the cross section of this circular shaft there, let me draw it clearly in the mid, and this is the horizontal axis. So outer radius R outer is given as 80 millimeter. So in meter it will be 0.08 meter, and inner radius is Ri, which is not known. So moment of inertia for this hollow circular pipe will be equal to pi by 4. Outer radius power 4, outer radius is 0.08 meter minus inner radius power 4. What will be C? C is distance from neutral axis till topmost. So this distance will be also C. So C is equal to R outer, which is equal to 0.08 meter. Now you have all the value allowable. Our maximum allowable stress is given, maximum moment is available, C is also available, and I is also available. Just put the value. Allowable stress is given as 150 megapascal. So what we will do is that 150 into 10 raised to power 6 is equal to maximum bending moment is 10 kilonewton. So 10 into 10 raised to power 3 will convert into Newton into meter. C is 0.08 divided by I, and this I is pi by 4 0.08 power 4 minus Ri power 4. So what we will do is we will bring this whole term to this side. So it will be equal to pi by 4 into 0.08 power 4 minus pi by 4 minus Ri power 4 is equal to 10 into 10 raised to power 3 into 0.08 divided by 150 into 10 raised to power 6. So if you expand it, it will be equal to pi by 4 into 0.08 power 4 minus pi by 4 Ri power 4 is equal to this term. Same. And now you need Ri. So pi by 4 into 0.08 power 4 minus 10 into 10 raised to power 3 into 0.08 divided by 150 into 10 raised to power 6 will be equal to pi by 4 Ri power 4. So in short, Ri power 4 will be equal to 4 times 4 over pi times pi by 4 into 0.08 power 4 minus 10 into 10 raised to power 3 into 0.08 divided by 150 into 10 raised to power 6. And what if you take cubic R4? If you take Ri power 4 cubic and same over here. So you will get Ri. And this Ri will be equal to 0.07646 meter, and in millimeter Ri will be equal to 76.46 millimeter. Now we are interested to find out thickness. So what we will do is that this is thickness T, and this T is equal to R naught minus Ri. R naught is 80 millimeter and Ri is 76.46 millimeter. So you will get this thickness will be equal to 3.54 millimeter. So this is the answer. Now we will counter check it with the shear force, shear stress. So what I will do is that shear stress. We know that allowable shearing stress or maximum shearing stress is given as V max into Q divided by I into T. So V max from shear force diagram, V max is equal to P is equal to 10 kilonewton. Let me show you. You can see V max is 10 kilonewton. Clear? So the cross section is circular with inner and outer radius is now available. Clear? And let this is horizontal axis or neutral axis. So we will find Q. So Q will be equal to, we will find the Q of this portion, shaded portion, because this portion is hollow. This is the shaded portion, solid portion, and we are interested to find out the Q for this. So what we will do is that we will first take this as one member solid semicircle 1 and this solid semicircle 2. So we will subtract Q1 minus Q2, which will give you Q. Clear? So we will take this as semicircle solid, which we will find Q1, and for this we will find Q2. So Q1 minus Q2 will give you this shaded portion. Clear? So it will be equal to Q1 minus Q2. Now you can see that Q1 is equal to Y1 dash into A1 minus Q2 dash is Y2 dash into A2. What will be Y2 dash? So Y2 dash will be, Y1 dash will be this distance. Distance from neutral axis till mid of this semicircle Y1 dash bar. And that will be equal to 4 over 3 R outer, 4 over 3 pi I R outer. Clear? And what will be Y2? So Y2 for this inner semicircle, it will be Y2 dash. And this Y2 dash bar is equal to 4 over 3 pi R inner. Clear? And area, so Y1 dash is 4 over 3 pi R outer, which is 0.08. Clear? Into area A1 of this semicircle having outer radius Ri. R outer, sorry. So which is equal to area of semicircle is pi by 2 R square. So 0.08 whole square minus 4 over 3, which is Y2 pi Ri is 76.46, which is 0.076 meter, clear, into semicircle, smaller semicircle, this one. So pi by 2, 0.076 whole square. So when you solve this, you will get Q max, and that Q max will be equal to 48.682 into 10 raised to the power minus 6 cubic meter. Now you have this Q max as well. I is given as pi by 4 C or R naught outer power 4, which is 0.08 power 4 minus R inner, which is 0.076 power 4. Clear? So when you solve this, you will get I will be equal to 1.8994 times pi into 10 raised to the power minus 6 meter over 4. Now you have this value. What will be the thickness? So thickness will be equal to this thickness plus this thickness. So this thickness is 2 times 3.54 millimeter. So thickness will be this one. Now in given question, it is given that determine the minimum wall thickness nearest millimeter. So what we will take is, we will take T is equal to 4 millimeter. Clear? This will be the answer. So here we have taken T is equal to 4. So we will take 2 into 4, which is equal to 8 millimeter. And this thickness will be equal to 0.008 meter. Now you have this value, you have this, you have this, you have maximum shear force. So put it in this formula, you will get maximum shearing stress. So maximum shearing stress is equal to maximum shear force into Q max divided by I into T. So maximum shear stress is 10 into 10 kilonewton. So 10 into 10 raised to the power 3. Q is 48.682 into 10 raised to the power minus 6 divided by I, which is 1.8994 times pi into 10 raised to the power minus 6 multiplied by thickness, which is 0.008. Clear? Again, when you calculate it, you will get maximum shear stress comes out to be 10.20 into 10 raised to the power 6 Pascal, which is equal to 10.20 megapascal. So this is the maximum shearing stress. Now you can see that this maximum shearing stress is either greater or less. So for that you have to check with the allowable shearing stress. So allowable is 85 megapascal. So your maximum shearing stress is less than allowable shearing stress. Maximum is 10.20 megapascal. which is less than 85 megapascal. So what does it mean? It means that thickness of this shaft is 4 millimeter, and that will be answer. And that was all about this problem 11-24. I hope you have enjoyed this video. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.